Hi, Mr. T here. This is the second video in the series of Level 1 Physics, specifically for those of you who are doing NZQA or NCEA. And in this video we're going to look at introduce motion, and specifically we're going to look at speed and how we use distance and time to calculate the speed for objects. Okay, so what is motion? Any object that is moving is said to be in motion, and it has specific quantities that relate or describe its motion. These quantities could be distance, time, speed, acceleration. If we're doing physics that's beyond maybe this level, we might use force as well, but we're going to focus at the moment on distance, time, speed, acceleration. So the first type of calculation that we need to do that isn't a direct measurement is how do we calculate the velocity of an object. So we can directly measure the distance of an object. We can take a tape measure from the start to the end and measure it off the tape measure. We can time how long an object takes to get from one place to another by starting and stopping a stopwatch. However, we can't it isn't as easy to work out the velocity, and we're going to have to do some calculations to work that out. So when I say velocity, I mean speed. So velocity is the physics word that we use for speed, and at year 11 we use the word speed. So speed is a concept, is how far an object went in a specific amount of time. In order to work out the speed of an object, we measure how far it has gone and we divide it by how long it took to get there. Because of that, because we divide distance by time, we end up getting a unit that is meters divided by seconds, or we say meters per second. And when we write that, it looks like ms -1. We use the following formula to calculate our speed. Notice that the symbol for speed is V, because in physics, when we get to higher levels, instead of saying speed, we're going to use the concept velocity. But at this level, V is speed. Okay, so speed, excuse me, I will get rid of that, measured in meters per second. Now you can see here this wee d that has a triangle in front of it. We're going to just ignore the triangle most of the time. What the triangle means, it's a Greek letter delta, it's a capital D, delta in Greek, and it means the change in. So it's the change in distance. So if a car went from the start of a 100-meter track to the end of a 100-meter track, the change in its distance is 100 meters, which would be just what you would say it was anyway. And then delta t at the bottom also means the change in time. When we rewrite this equation and work with it, we'll often just leave out the triangle or the delta. So, how do we calculate the speed of an object? Well, here's a question. A car travels 13 meters in 1.5 seconds. Here's an illustration. Here's our car, 13 meters, 1.5 seconds. So how do I calculate the average speed or the speed of the car? Well, first thing, we want to identify what we already know. We know the distance, or the change in the distance is 13 meters. We can see here that the time is 1.5 seconds. So we can use this equation we've just been given, this one here, V equals d over t. Now remember, I said I'm just going to leave out the change in, the big triangle in front of the D and the triangle in front of the T. That's not necessary for us to work out these problems. So now what we know is we know that if we want to find speed, or V is its symbol, we need to replace the D in the equation with the value we have for D, and replace the T in the equation with the value we have for T. So we do that, we replace D with 13 and T with 1.5, and we end up with this equation. So what we do now, we've got a fraction, we've got a numerator and a denominator. So we divide our numerator, that's 13, by our denominator, 1.5, and we get our answer. Here we go, 8.667. I put the unit down for speed. This is the unit that we went over the last video. And this is my answer, apart from maybe not. Let's try and keep our answers here to what we say is 2 significant figures. Because we could actually write down lots of significant figures for this answer, but I'm just going to simplify it, and we're going to round it here to 2 significant figures. So here the velocity is 8.7 meters per second. So here we are, we've calculated the velocity using the equation v equals d over t. We replaced the d and the t with their actual values for d and the t, and we came up with an answer. So we have now done our first physics equation. It's really just an algebra equation. We substituted numbers in for letters. Okay, so let's look at another example of a question that we might be asked to do with speed. Here's the question. What is the distance travelled by a car that has an average speed of 30 meters per second for 15 seconds? This question is similar to many physics questions, and because they're very similar, I've made a series of 5 steps that we can use to solve any of these questions. And if we approach these questions using the 5 steps I've got on the right here, we can usually answer any question given to us. Okay, so the first step here, number 1, identify the subject of the question. What is it I need to find out from this question? Let's read this question again. What is the distance travelled by the car? That is the subject, the distance. That's what we want to find out. So I'm going to circle it. I'm going to call it the subject. What are the values or the quantities that are given to me in this question? Remember, a quantity has a numerical value, a number, and a unit next to it. So let's have a look and see if we can find some. The first quantity is the 30. It has the unit ms, -1, next to it, so it's speed. I know it's speed as well because it has a label of the average speed just before it. So I'm going to take that quantity and I'm going to write it down in my working. Speed equals 30 meters per second. Notice instead of writing speed, I give its abbreviation v. The next quantity I can see here is 15s. They haven't told me what this quantity is, but I can see that the unit is s for seconds, so this quantity must be time. So I'm going to write this down in my working as well. The time is 15 seconds. We now go to the third step. We're going to use the equation to solve this problem. Now, to choose the correct equation, I have to realize that I've got the subject distance, which is d. I have 2 quantities, v and t, so I'm going to find an equation that has d, v and t in it. Yeah, it's the equation we've looked at so far, the only equation we've seen so far. But there are many others. So here's our equation. We can find the velocity if we divide the distance by the time. But we don't want to find the velocity, we want to find the time. So I have to do something called rearranging this equation. I'm not going to go over how to rearrange the equation in this slide. That'll be the basis of the next slide. The whole next slide will go over how to rearrange equations. But once we rearrange it, we can move the time to the other side and we get the equation looking like d equals v times t. So we just did the 4th step. We rearranged the equation. All that I need to do now, substitute in the values, replace v with its value of 30, replace t with its value of 15, and then we multiply. Put the numbers in our calculator, multiply them together. We get a distance, 450 meters. That is our answer. It's 2 significant figures, so I'm quite happy. That's how we solve physics problems, and this is also how we work out or how we use velocity, or what velocity is. I hope this video has been helpful. Remember, look out for the next video. I'm going to go through how we do step 4 specifically, how we rearrange problems.